Normalization in SQL. Hi, my name is Molly Mobley, and this is a presentation that was prepared as part of the HAP 671 course on healthcare databases taught by Farouk Alimi, PhD, and Savitra Shantalapani at George Mason University Department of Health Administration and Policy. I'm currently a registered nurse enrolled in George Mason University's Master's in Health Informatics with an anticipated graduation of December 2023. On this agenda, we will be defining normalization, asking why normalization, discussing design principles, and discussing normal forms. Normalization is defined as the process of reducing the redundancy of data in the table and improving the data integrity. When performing normalization, we are applying principles of design to data structure so that they conform to our expectations. It usually divides a large table into smaller ones so it is more efficient. So why normalization? Without normalization in SQL, we may face many issues, such as insertion anomalies, which occur when we cannot insert data to the table without the presence of another attribute, update anomalies, where data inconsistency results from data redundancy and has a partial update of data, and deletion anomalies, which occur when attributes are lost because of the deletion of other attributes. If data is not normalized, we are unable to proceed with further analytics due to the anomalies. In addition, it can also consume increased amounts of storage space. There are 5 design principles that one must follow, developed by mathematicians as a requirement for effective and efficient databases. Each table should correspond to a single entity. Rows in the table should correspond to individual occurrences of the entity. Primary key should uniquely identify the individual occurrences of the entity or relationship, and non-key fields should be facts about the occurrence identified by the primary key. Each fact should be presented only once in the database. There are various levels of normalization. You have first normal form, second normal form, third normal form, Boyce-Codd normal form, fourth normal form, and fifth normal form. In this presentation, I will be discussing the first, second, and third normal forms. To be a first normal form, it's defined as having single-valued attributes. The attribute domain does not change. There's a unique name for every attribute column, and the order in which the data is stored does not matter. As you can see here in this table, in column student phone, there are multiple valued attributes listed in the first row. The second table demonstrates converting the first table to its normal form by providing an entire row for the previous multiple valued attribute. A relation that is in first normal form in every non-primary key attribute is fully functionally dependent upon the primary key, then that relation is considered in second normal form. Second normal form, again, must be in first normal form and is considered a removal of partial dependencies. These tables here to the right are an example. Here, course fee alone cannot decide the value of course number or student number. Course fee together with student number cannot decide the value of course number. Course fee together with course number cannot decide the value of student number. Therefore, course fee would be a non-prime attribute as it does not belong to the only candidate key. But course number reflects course fee, and course fee is dependent upon course number, which is a proper subset of the candidate key. Non-prime attribute course fee is dependent on a proper subset of the candidate key, which is a partial dependency. So this relation is not in second normal form. To convert the above relation to second normal form, we need to split the table into 2 tables, such as Table 1 and Table 2. You can see here that we have split them with student number and course number, and then course number and course fee. Third normal form must be in second normal form and have no transitive dependency. Third normal form ensures a reduction of data duplication. Transitive dependency is when a non-prime attribute depends on another non-prime attribute rather than depending upon the prime attributes or primary key. With exam name and total marks added to our score table, it saves more data now. Primary key for our score table is a composite key, which means it's made up of two attributes or columns, which are student underscore ID and subject underscore ID. Our new column exam name depends on both student and subject. For example, a mechanical engineering student will have workshop exam, but a computer science student would not. And for some subjects you have practical exams, and for some you do not. So we can say that exam name is dependent upon both student ID as well as subject ID. And our second new column, total marks, does it depend on the scores table primary key? The column total marks depends on exam name, as with exam type, the total score changes. For example, practicals are of less marks while theory exams are of more marks. But exam name is just another column in the score table and is not a primary key or even part of the primary key, and total marks depends on it. To remove transitive dependency, we take out the columns exam name and total marks from score table and put them in its own new table called exam table and use the exam ID wherever required, thus achieving the third normal form. In summary, with normalization, data is simplified, easier to extract, and allows lesser amounts of storage needed. Thank you for listening to my brief presentation on normalization in SQL.